Number 10 is also a BIDMAS question, but a different style. You have to insert brackets if necessary to make these calculations correct. Only if necessary. If they do not need brackets, don't put them in because you are showing that you know they don't need them. Even if putting brackets in would still make it correct, if they don't need it, don't put them in. So on part A, I would do the multiplication first here. Normally that would give me 6 plus 7, 13, not equal to 20. So the only sensible place to put brackets here to stop me doing that multiplication first is there. That would give me 10, 2 lots of 10 would make 20. On part B, I would do the multiplication first normally. That would give me 30 plus 2 gives me 32. So actually no brackets are needed in that one. On part C, I would just go from left to right here because I've just got subtraction and addition and they are equal priority. So 9 minus 3 would give me 6, plus 2 would give me 8, so that's not right. So if I put brackets around the 3 plus 2, that would give me 5 in the bracket. 9 minus 5 would give me 4. On D, I would do the division first normally, so that would give me 18 times 3 would give me 54, plus 4 would give me 58. So that's not right. If we put brackets around the 2 times 3, that would give me 6. 36 divided by 6 is 6, plus 4 is 10. On part E, if I use BIDMAS, I'll do 4 times 5, which would give me 20. 2 times 3 would give me 6. 20 add 6 would be 26. So the brackets need to go around the 5 plus 2. So 4 times 7 would give me 28. Times that by 3. So 28 times 3 would be 84, so that works. On part F, if I use BIDMAS, I would do this first, which would give me 20. And then this would give me 5. 20 plus 5 is not 15. So the brackets need to go around the 4 and the 10. And then that would cause me to do this bit first. So 20 plus 10 is 30, divided by 2 is 15. Okay, on number 11. Express 360 as a product of its prime factors. So a product means a multiplication, and prime factors are factors which are prime. So I would normally use a tree for this to decompose into prime factors. If I can squeeze it in here. So 360 is 2 lots of 180. That's not that's not prime, but 2 is. 180 is 2 lots of 90. 90 is 2 lots of 45. 45 is 3 lots of 15. 15 is 3 lots of 5. Okay, there are other ways of doing it. So 360 is 2 times 2 times 2 times 3 times 3 times 5. Or we could write it as 2 cubed times 3 squared times 5. Number 12. Given that 240 is 2 to the power of 4 times 3 times 5, and 252 is 2 squared times 3 squared times 7, and that y is equal to those two numbers times together, write y as a product of powers of its prime factors. So in other words, write y as a product of its prime factors. So if 240 is this number and 252 is this, then their product, when I times them together, is the product of all of these things as well. Okay, so I'm simply going to have 2 to the power of 6 because I've got the 2 to the power of 4 timesing by the 2 squared here, and I can add the powers. I've got 3 to the power of 1 here times 3 squared, so that's going to give me 3 cubed. I've got a 5 and I've got a 7, and that is the answer. So let's just write that on the number line, sorry, the answer line. Now we have to give it with powers because it said to simplify our answer. Okay, number 13, find the highest common factor of 36 and 60. Now these are relatively low numbers to find factors of, so probably the easiest method for these is just to find all of their factors and therefore find the highest one in both lists. So I like to do this in pairs. That way I don't miss any out. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. In brackets, okay, would make 36. For 60, I've got 1 and 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. So the highest number in both lists, if I start at the high numbers and work my way down, is 12. 12 is in both lists. Okay. The lowest common multiple of 9 and 15. Again, these are quite low numbers and ones that are quite easy to work out some multiples of. Remember, multiples are in the multiplication tables of these things. So if I write out the multiplication table of 9 times table in other words, 9, 18, 27, I'm just going to think in the back of my mind, testing each of these to see whether 15 goes into it. 36, I haven't got to one yet. 45, now 45, let's check that one. 15, 30, 45, yeah, so 45 is the lowest common multiple of those two numbers. Okay, up to the next side. Buses to Alton and Bakewell leave a bus station at 7 AM. Buses to Alton leave every 24 minutes and Bakewell leave every 20 minutes. When will buses to Alton and Bakewell next leave at the same time? So this is a lowest common multiple question in disguise. When will these, what number do these both go into? That's what we've got to figure out. So we need to find the lowest common multiple of 24 and 20. Now ignore the fact that it's time for a minute and just deal with that. So if I write up some multiples of 20 until we get to one that we think 24 goes into. So 20, 40, 60, 80, 100, 120. Okay, let's write out some multiples of 24. 24, 48, 72. You have to be careful here that you don't make any mistakes. 96 and 120. So they both go into 120. Oops. So 120 is the lowest common multiple. So 120 minutes after 7 AM. So 120 minutes. How many hours is that? That's 2 hours. So 2 hours after 7 AM would be 9 AM. Okay. Number 16, we're given two numbers as products of their prime factors. Now we could work out what A and B are if we wanted, what they actually are as numbers. They're not very big numbers, but we don't need to. Find the highest common factor of them. So the highest common factor is the product of all the prime factors that they share. So they both have at least two 2's. So I'm going to put two 2's in the middle of their Venn diagram. I'm sure most of you will have seen this in your lessons. They also both have a 5. So the lowest common multiple is 2 times 2 times 5. So 2 times 2 is 4, times 5 is 20. The highest common factor, we use the other leftover numbers. So A also had a 3, but it wasn't shared, so I'll put it there. And it also had another 5. B had another 2, but the 5 it had is already accounted for in the middle of the Venn diagram. So the lowest common multiple we get by timesing all of these numbers together. So I already know that the middle bit is 20. So 2 lots of 20 is 40, times 3 is 120, times 5 is 600. Okay, 17. Work out the value of 3 squared plus the cube root of 8. So 3 squared is 9, cube root of 8 is 2. 9 plus 2 is 11. Okay. Number 18, 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. 3 cubed is 27, and 10 to the power of 4 is 10,000. So this is 10,043. These numbers in standard form I need a digit between, or some digits between 1 and 10, so 5.12 are the digits I'm going to use to represent this number. Remember, standard form means times 10 to the power of something. Now, how many times do I have to move the decimal point from where it is now at the end of the number to where I want it between the 5 and the 1? There. Okay, so it's got to move once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. So times 10 to the power of 7. This one, the digits I'm going to use are 2, 5 and 6, but the decimal point needs to go after the 2, so 2.56. How many times do I need to move the decimal point from where it is now to get it to here? So let's count that. 1, 2, 3, 4, 5, 6, 7 times, but 7 in the opposite direction, so -7. There we go. And the last question on that page, write the following as normal numbers, so change from standard form to normal. Write out the digits, 3 and 2. I know this is going to be a very big number because it's a positive power. I'm going to just put my pen where the decimal point is now and count back 4 times. 1, 2, 3, 4. That's where it is now. I need to fill in these gaps with placeholder zeros. So the answer there is 32,000. And this one, part B, is a very small number because I've got a negative power here. It's not a negative number, it's a very small number. So I'm going to put my 3 and my 5 over this side of the answer line. The decimal point is between them at the moment. I'm going to move it 5 times the other way. 1, 2, 3, 4, 5. That's where it goes. Fill in the gaps with zeros, and also we need a 0 in the units. Okay,